Hello everyone, today we'll be doing some examples on the definition of real numbers. So basically it's just playing around with the definition, okay? Like how do we define integers, how do we define natural numbers, and even numbers, odd numbers, stuff like that. Okay, so let's get started. The first problem, solve the following equations. 2n plus 19 equals 7, where n is an integer. So let's first note integers are blah blah blah, minus 2, minus 1, 0, 1, 2, 3, dot dot dot. So basically it's telling us as long as the solution n is not a decimal, a fraction, well, you get what I mean, right? I'm doing a pretty bad job explaining, but let's get started to solve it. Plus 19 equals to 7. Okay, so we just subtract both sides by 19 and we get 2n equals to negative 12. And then we divide both sides by 2 to get negative 6. So you see negative 6 is a member of the integers. So it satisfies the condition n is an integer. Okay, so the solution is 6. So the solution is n equals to 6. And we're done with the first one, part A. Now part B. Again, we have to solve the equation, but this time n is a natural number. Okay, so this time I'll write it in a different way. N belongs to, this means belongs to a member of whatever you like to call it. No, actually, let me not use the set. 1, 2, 3, dot dot dot. So, oh, look, my notation is pretty just freestyle. So, yeah, just for you to understand. Okay. Now, 3n plus 8 equals to 5. Subtract both sides by 8. Again, negative 3. Divide both sides by 3. N is negative 1. So, is negative 1 a natural number? Well, no, because the natural numbers are always positive, and when you see negative 1, you immediately know, hey, it is an integer, but it is not a natural number. Therefore, what does that mean? This equation has one and only one solution, n equals to negative 1, but negative 1 is not a natural number, so we say that it has no solutions. It has no solutions that satisfies the question's requirement. It has no solution, or S, I don't know. My grammar is so bad. Okay, so we've KO'd these two problems, and let's move on. Now this is more interesting. It's given that big N is an integer. So again, integer is just, well, positive and negative version of natural numbers. Prove that A, 2n plus 2 is an even number. Okay, so let's do it. Now, what is even numbers? Well, even numbers are those numbers that can be divided by 2, right? So it also means that it has a factor of 2. So for example, 6 we know it's even, right? 6 is even. Okay, example, 6 is even, and its factors are 1, 2, 3, and 6. So you see there is a factor of 2 inside, and that's why it can be divided by 2. Okay, therefore we're looking for a factor 2 inside this expression. And how do we do that? well, it's not difficult to see that we can factor out the 2, right? Because if we distribute, you see that is a 2n, distribute the 2 to the 1, positive is just positive, plus 2, and it's exactly the same thing when we started. That means, well, we have a 2 in the front, so it's a multiple of 2, and if this thing is a multiple of 2, then it can surely be divided by 2, because you see, if we divide it by 2, it's just n plus 1, and because n is an integer, n plus 1 is also an integer. That means it is fully divisible by 2. Good. So we actually already proved it. But well, yeah, I gonna just write down, because n is an integer, that means n plus 1 is also an integer, and that means 2n plus 2 is even. Okay, my super bad handwriting. Anyways, that's how we prove it. Part B. Let's hope the video is not too long. Part B. Prove that 2n plus 1 squared is an odd number. So it's an odd number. That means it is not divisible by 2. Okay, so let's do it quickly. I hope you can follow. 2n plus 1 squared. Okay, we just expand it, right, by the FOIL method, or whatever you like, the identity. So a squared plus 2ab, 2 times 2 is 4, so that's 4n plus b squared. B squared, 1 squared is just 1. Now we factor out a 4, which is 2 times 2. I'm writing it this way for a reason. So you see, the first term is absolutely divisible by 2, right? Because you have 2 factors of 2, which is also which also has 1 factor of 2. But the problem is this plus 1. Now we know that every consecutive number is divisible by 2. For example, 4 is, but 5 is not, 6 is, but 7 is not. So if this thing is divisible by 2, then when we add 1 to it, for example, like 4, we add 1 to it, it goes to 5, and it is not divisible by 2. So this is not divisible by 2, which means it's odd. It's odd. Okay, so I'll leave part C to the next video, I think, and see you.